Hey there, AP Pre-Calc friends. This is Miss Adams from Flamingo Math. We're going to graph sinusoidal functions and work on transformations today. This is lesson 3.6, day 1 for us. We have a standard form equation right here at the top of the slide where we have the values A, B, C, and D. And we want to discover what those characteristics of the function do to our transformations. Yesterday we saw the key points when we had a sine curve. The sine curve for a positive A value had 5 key points that were intercept, maximum, intercept, minimum, and intercept. But if our A value was negative, our graph reflected over the x-axis and our key points were intercept, minimum, intercept, maximum, intercept. We know that the A value is our amplitude of our function, and we always name the amplitude non-negative. It's the absolute value. We know that our C value here in this case is our starting point, and we know that the D value is our midline, and we know 2 pi over b represented the period for the function, how long it took to complete one cycle of our sine curve. In a similar fashion, we also saw that when we had the cosine function, the key points when the amplitude was positive for cosine began with a maximum, an intercept, a minimum, an intercept, and a maximum. But when we had a negative A value, our graph reflected across the x-axis, and we had key points that started with a minimum, then an intercept, maximum, intercept, and minimum. And just like our sine function, A was our amplitude, D was our midline, 2 pi over b was the length of one cycle or the period of the function, and C in this case was our starting point. We see on the next slide that we have the definitions for those characteristics for the transformations. The length, the absolute value of A changes the height of the graph. It's a vertical dilation. We have the length of one complete cycle by finding 2 pi over b. We have the horizontal translation or starting point, and if you have an x plus c value, then x is the opposite of c. That's going to be a shift to the left. If there's an x minus c, that's a shift to the right. And this is our midline, the value for d. And the b value is the number of cycles in the interval from 0 to 2 pi, and then the final frame, b times x plus c. This expression we call the argument of the function. Let's look at graphing by key points using that formula. In example 1, we have y equals 3 times the sine of 3 times the quantity x minus pi over 6. So first we want to know amplitude. So our amplitude is 3 in this case, and the function is a sine function. So our key points are going to be in the pattern of intercept, maximum, intercept, minimum, and finally intercept. Now we know that the C value is where we start. So our starting point is at pi over 6. We can think of x minus pi over 6, and solving that for 0 gives us our starting value, pi over 6. Now, if we want to find the period, we're going to calculate 2 pi divided by the b value. B is 3, so 2 pi divided by 3 is the period. And we can get our stopping point, I like to do this. If this is our starting point at pi over 6, and it's going to be an intercept, and then we have to go 2/3 of a pi. So 2/3 of a pi from our starting point, pi over 6 is where we start. We're going to go 2/3 of a pi, which is 4 pi over 6. So we're going to stop at 5 pi over 6. This is our stopping point, 5 pi over 6. It's also an intercept. So if we start here, and then our period is 2 pi over 3, this is one period. Our stopping location is 5 pi over 6. Now, just like any journey, we have a starting place and a stopping place and a halfway spot. That's an intercept. So halfway is at pi over 2. And in between, halfway between the intercepts, we first have a maximum point, and the maximum is a stretch of 3. So our maximum would be at pi over 3. And then we also have a minimum halfway on the second half. So at 2 pi over 3, we have a minimum. There we have the 5 key points of our one complete cycle, from pi over 6 to pi over 3 to pi over 2, 2 pi over 3, and 5 pi over 6. So we know where our graph is going, and we know that the midline had to be the x-axis because there was no number added at the end of the equation. So that was pretty straightforward, and we could complete that graph and graph another period. And you notice that each line we're doing something. So if we have an intercept, max, intercept, min, intercept, max, intercept, min, you can complete that 2 full cycles, almost 2 full cycles on that grid. Now you can give cosine on example 2 a try on your own, or you can follow along with me. I'm taking my argument x plus 2 pi and setting that argument equal to 0 to know that my starting location is at negative 2 pi. I want to start my graph here. And then I want to know what the period is. So 2 pi over b, our b value is a half. 2 pi over b is 4 pi, so the period is 4 pi long. If we start at negative 2 pi and the period is 4 pi, we're going to stop at 2 pi. This is our stopping spot. So already you know that you're going to start, your graph is going to go maximum, intercept, minimum, intercept, maximum, and we're going to start at negative 2 pi and we're going to stop at 2 pi. So the A value is the stretch on the graph. That happens to be 2. And again, there is no D value. So our midline again is y equals 0, or the x-axis. So our maximum is at negative 2 pi 2. And we're going to end at a maximum. In the middle, where's the middle? At 0, our middle will be 0. We're going to have a minimum. And then an intercept halfway between negative 2 pi and 0. So that would be at negative pi. We have an intercept. We have another intercept at pi intercept. And we have one complete cycle. Maximum, intercept, minimum, intercept, maximum. So the period of our function is 4 pi to complete one cycle with the 5 key points and an amplitude of 2. Now, at the bottom of our notes, they want us to compare and contrast what occurred to the period when b was greater than 1 and what occurred to the period when b was in between 0 and 1. Can you put that into words? If B is greater than 1, you have a horizontal compression. So that shrinks the graph closer to the y-axis. And if you had the B value between 0 and 1, that was a horizontal stretch or a dilation. It made the graph take a lot longer to complete one period. When the argument is C less than 0, then the phase shift is to the right. So X minus C made our phase shift right, but X plus C made our phase shift to the left. Next, we're looking at vertical shifts or changing the midline. So if we have sine of X plus 1, this plus 1 is outside of our argument. You could really think of the sine curve as having sine with parentheses X. So the plus 1 is shifting our function or our midline 1 unit up. And same with example 4, this is a shift downward. So our midline moves 2 units down here. This is our midline. It's like a new x-axis. You could label that x prime if you wanted, to give your mind a place to focus on where those intercepts are going to be. In the first one, the sine curve starts at 0 and stops at 2 pi. And the pattern is intercept, maximum, intercept, minimum, intercept. This is one cycle, one period. You can continue on, intercept, max, intercept, min. But for cosine, we start at a maximum point, so at 0, -1, and we stop at a maximum point. That would be 2 pi -1. Halfway in the middle, we have a minimum at pi -3. And then the quarter way is an intercept, and 3/4 of the way is an intercept. And there's our maximum intercept, minimum intercept, maximum intercept, minimum intercept, continuing for 2 complete cycles. So here's the note that we have in our notes. If you have plus D at the end, then the vertical shift of the entire graph is equal to D. The midline of the graph is Y equals D. Here we want to summarize what we've found out. The variable expression for amplitude is A, but we want the absolute value always. This is half the height of the wave. I'm going to put wave in parentheses, half in quotes, half the height of the wave. It's a vertical dilation. The period, we can find the period by evaluating the expression 2 pi over b. Again, I'm going to put absolute value bars around the b. That's the length of one full cycle of the wave or the curve, sinusoidal curve. The phase shift is c, and we could say this is a horizontal shift. It's the first key point. I'm going to put key point in quotes of a cycle. And then the vertical shift is the D value, and we're calling this the midline because it moves the entire graph. It's like a new x-axis, we said. It's going to move that entire graph up or down. So those are the main key points to get us started in this lesson, and you'll have some practice. and join me tomorrow and we'll finish this lesson on sinusoidal transformations.